Hi everyone, in this video we are looking to become more precise with this idea of a function. So we have several of these goals. We have some vocab words we're going to be learning, such as domain, range, a mapping diagram, and a vertical line test, and using something called function notation. Okay, so far what we've learned about functions is that it's basically this machine where an input comes in to the function and it has exactly one output. Now in today's lesson there's really three types of problems. Okay, so the first type of problem will hit these goals. The second type of problem will be over the vertical line test. And last we'll learn about function notation. So learning about the words domain and range, a mapping diagram, and determining if we actually have a function. Okay, so for this particular problem we have just a bunch of ordered pairs. Okay, so first thing we can do is determine the domain and range. So the domain is all possible x values, whereas the range is all possible y values. So determining the domain, for domain I'll just put a D. I'm going to use these curly brackets for a set, and then all possible x values. So I have a 3, and what I notice is that all my x values are 3. So that means that the only possible x value is the number 3. Now for the possible y values, or the range, I have possible values of -7, 8, -2, 4, and 1. So I'm just going to put these from smallest to largest. So my smallest number is -2. Then I have 1, 4, 7, and 8. So my domain, my possible x values is 3. My range, my possible y values are -2, 1, 4, 7, and 8. Okay, so creating a mapping diagram. Okay, so a mapping diagram would be you're making two boxes, one for domain and one for range. In domain, just putting in the numbers, we have the number 3. For range, we're going to list the numbers -2, 1, 4, 7, and 8. And then we're simply drawing arrows. So 3 maps to 7. That's my first point right here. Then I have 3 maps to 8. So 3 arrow to 8. Then I have 3 arrow to -2 for my third point, 3 arrow to 4 for my fourth point, and 3 arrow to 1 to my next point. So what this basically means is that if we have this function machine, then 3 is the input, but we have all of these numbers coming out. You know, we have -2 and 1, 4, 7, and 8. So therefore, this is not a function. So anytime you have ordered pairs, you have a relation. But this is not a function, because function means one input out, one input in, one output out. But here we have all of these outputs. So therefore, this is not a function. So again, this is not a function. So for this example, okay, so determine the domain and range. Domain would be all possible x values. So we have -3, 2, 5, and 9. -3, 2, 5, and 9 for domain. For the range, my possible values are 5, 7, 4, and 5. So I don't have to repeat the 5, so I could just say that my possible y values are 4, 5, and 7. Next step is to make a mapping diagram, so listing all the possible x values in one box, -3, 2, 5, and 9. Listing all of the possible y values in the other box is 4, 5, and 7. And now we're drawing arrows. So the 2 matches with the 5 from this first point here. The 5 matches with the 7 from the second point. The 9 matches to the 4. And the -3 matches to the 5. So what's important here when we take a look at our mapping diagram is that no number in the input has 2 arrows coming from it. It's always 1 in, 1 out, 1 in, 1 out, 1 in, 1 out. So therefore, yes, this is a function. Compared to this one, where this one number 3 had all of these arrows coming from the 3. So since it had all the arrows, this one is not a function, whereas this example is a function. So a function has nothing to do with patterns or anything else. It's just simply, does each x value have a single arrow in a mapping diagram? And here we see that they do. So yes, it's a function. Our next goal is to apply the vertical line test. The vertical line test tells whether a graph is a function or not. So this says, is it possible to draw a vertical line, vertical means up and down, that crosses through more than one point? If yes, the relation is actually not a function. If no, if it's not possible to draw a vertical line through more than one point, then yes, it is a function. Okay, so taking a look at this example, so this is a discrete graph because it's just a bunch of points. Okay, so drawing vertical lines. Okay, so this vertical line only goes through one point, only through one point, only through one point. So all these vertical lines only go through a single point. So that means that yes, this is a function. Because the notes say that, is it possible to draw a vertical line through more than one point? No. All of them just go through a single point. Therefore, this is a function. Yes, this is a function. Next example. Okay, so all my vertical lines only go through one point. So yes, this is a function. Next example, drawing vertical lines. The problem is right here because this vertical line goes through 2 points. Therefore, this is not a function. Here, okay, so this is a continuous graph, but still I can imagine that I could draw all these infinite vertical lines, and all the vertical lines only cross through one red point. So therefore, yes, this is a function. In this example, okay, so a graph of a circle. Okay, so if I draw vertical lines, a lot of these vertical lines cross through 2 points. So since the vertical lines cross through 2 points, then no, this is not a function. Drawing vertical lines through this graph, over here it's okay, it only crosses through 1 point. But over here, it crosses through 3 points. So since it crosses through more than 1 point, then no, this is not a function. The last goal of the lesson is to use function notation. Okay, so first of all, this problem is a review. We're just creating a table for some function. So we could plug 0 in for x, so 2 times 0 is 0. 0 plus 1 is 1. We could plug 1 in and get 2 times 1 is 2. 2 plus 1 is 3. And plug 2 in and get 4 plus 1 is 5. it turns out, so a notation is just another way of writing a problem. So it turns out that these two problems say the exact same thing. So the key learning is that instead of using a y, we are using this symbol right here. And that symbol is pronounced f of x. But f of x is exactly the same as the variable y. It represents just simply one unknown. Okay, so y is exactly the same as f of x. So whenever we have written like this letter and then a parentheses x, close parenthesis, we could replace that entire writing with the letter y and do the problem exactly the same. So in our table we have x and f of x instead of x and y, because y and f of x are identical. That means we could just plug 0 in for x, and this problem is exactly the same. So in this problem, this is pronounced p of x equals 3x. We can take this whole symbol, p parenthesis x, and replace it with a y. This is really just the problem y equals 3x. And then this right here is pronounced p of 0. But all we are doing is taking the number 0, plugging it in for x, and calculating. So to find p of 0, all you do is fill 0 in for x, and you'll have 3 times 0, which is 0. So we'll have 3 times 0, which is 0. So the answer of p of 0 is 0. Next question says to find p of 4, so we're taking the number 4, filling it in for x, and you get 3 times 4, which is 12. So with this function notation, we're just simply filling numbers in. This last problem, light travels at about 186,000 miles per second. The function d of t equals 186,000 t gives the distance d of t in miles that light travels in t seconds. How far does light travel in 30 seconds? So this problem is really just simply, if we replace this d of t with a y, it's simply y equals 186,000 t. So then what this question says is plug 30 in for t and calculate. So 30 times 186,000 equals 5,580,000 miles is the distance that light travels in 30 seconds. So the question is, how far does light travel in 60 seconds? If you can answer that one and put the answer into your Google form for the final question. Thanks. See you in class.